So let's suppose G is any non-empty set and star is any binary operation which is defined on G. So if star is a binary operation defined on G, what does it mean? If you consider any two element from G, you apply this operation, it is also a member of G. It is again a member of G. So that means G is closed under the binary operation star. So that means this star is defined on G, right? So we consider a non-empty set. Together with we are having a star which is defined on the elements of G, means this thing hold, right? Now if this set G with respect to this operation star satisfying some properties, then that set is said to be group. Now what are these properties? The first one is the set should be satisfying the associative property with respect to the binary operation star. Means what? If you consider three elements from G, this is a symbol for belonging. So if you are consider three elements from G, you apply the operation like this. You first apply the operation on A and B. जो भी आपके पास एलिमेंट आया उसके बाद आपने C पे अप्लाई किया. This is same as that. You first apply the operation on B and C and then apply with A. So if this thing hold, then you will say G satisfy the property associativity with respect to the binary operation star. Is it clear? The property associativity.
Yes, ma'am.
So if the elements of G satisfying this thing, you will say G satisfy the associative property with respect to the binary operation star. Next property is the existence of identity. Now what is the meaning of identity? Identity is that number in the given set. You consider any element from G. E should exist in G such that X star E is again X. Same element X ही आ जाए, right? और ये E exist करना चाहिए G में. अगर ये exist करेगा, only then you will say the identity exists in this G with respect to the binary operation star. So for any X belonging to G, if there exists E in G, and this E should be unique one with respect to the binary operation star. If there exists this E in G such that X star E is X or E star X, one and the same thing. Means commutative property hold होगा with respect to the identity and the operation star. If this thing hold, you will say identity exists in G with respect to the operation star. Now just see, for example, if I am considering the set of integers and if I am taking binary operation to be as addition, then what will be the identity?
0.
Yes?
0.
0. Yes, 0. Because you take any integer, let's suppose 2, and your operation is addition. What will you add over here so that again you will get 2? यही आपको चाहिए. X star E should be equal to X. So this number should be same as that this. क्या आप इसमें ऐड करोगे ऐसा so that again आपको same element मिले? Here the operation is addition. So we will take 0 and clearly 0 आपका integers में है. So we will say identity exists in set of integers with respect to the operation addition. अगर मैं set of integers की बजाय set of natural numbers लूँ, क्या तब आपकी identity exist करेगी with respect to the operation addition?
No, ma'am.
No. Why not? Again, आइडेंटिटी आपके पास 0 ही आ रहा है, बट 0 इज नॉट अ मेंबर ऑफ set of natural numbers. So therefore we will say that there does not exist identity with respect to the operation addition on a set of natural numbers. Is this point clear?
Yes, ma'am.
Yes, ma'am.
So existence of identity is clear to all of you.
Yes, ma'am.
Now the next is existence of inverse. Existence of inverse means what? For any non-zero element, जनरली हमें नॉन जीरो की रिक्वायरमेंट नहीं होती, कहाँ हमें रिक्वायरमेंट है? डिवीजन वाले ऑपरेशन के लिए, राइट? अदरवाइज आप इसको ओनली एलिमेंट भी कह सकते हो. सो फॉर एनी नॉन जीरो एलिमेंट x of g, there must exist an element y in G such that x star y should be equal to the identity. This identity will be the same जो पहले आपके पास आ चुकी है सेकंड प्रॉपर्टी के टाइम, राइट? सो ये प्रॉपर्टी आपकी पहले होल्ड होगी, उसके बाद आपने थर्ड वन चेक करना है. सो जैसे सेट ऑफ इंटीजर्स में 0 ऑलरेडी आ चुका है आपके पास, then we will check the third property that this thing hold or not, the existence of inverse. So we take any element from the set G, we apply the operation, we have to see क्या कोई ऐसा एलिमेंट एग्जिस्ट कर रहा है सच दैट ये चीज लेने पर आपके पास आइडेंटिटी आ जाए. जैसे set of integers, case of set of integers with respect to the operation addition, we know that 0 is the identity, right? So this identity is already exist in case of integers and that is 0, right? So we have to see that with respect to addition हम क्या ऐड करें x में so that we get 0.
minus x.
Minus of x. And clearly if x is your integer, then minus of x is also an integer. So this should exist in G itself, right? तो set of integers में ये already exist कर रहा है. अगर आपका 1 integer है तो -1 भी एक integer है. इन दोनों को आप add करोगे, you will get identity, right? And this is true for every element of set of integers. So that means inverse exists in set of integers with respect to the operation addition. Is it clear?
Yes, ma'am.
Okay. Rather taking addition, if I'm considering multiplication, then what will be the identity with respect to the multiplication and what will be the inverse with respect to the multiplication?
Identity element will be 1.
Yes, you consider any element, let's suppose 2, किससे multiply करो so that again you will have 2, that is 1. And clearly 1 is an integer, so 1 exists in set of integers. So identity exists in set of integers with respect to the operation multiplication. What about the inverse?
Does not exist.
Does not exist. Now why? Same for 2. If you consider 2, by which number you multiply so that you will have 1?
1 upon 2.
1 upon 2. Is 1 upon 2 to an integer?
No, ma'am.
No. So that means inverse does not exist in case of set of integers with respect to the operation multiplication, right? So therefore inverse does not exist with respect to the operation multiplication in case of set of integers, right? However, if you consider set of real numbers, then what will be the identity and what will be the inverse with respect to the operation multiplication?
Identity will be 1.
Yes, identity is 1 and inverse is if x is any real number, then 1 by x. that is also a real number, right? So when you multiply this, you will have 1, which is identity in case of real numbers. So here condition should be that x should be non-zero. So that's why we have taken this to be non-zero element, right? Only then we can divide by this. This point is clear?
Yes, ma'am.
So for non-zero element के लिए ही हमने inverse की बात करनी है, zero element के लिए नहीं करनी. So any set with respect to the operation satisfying these three properties. What are the three properties? Associativity, identity existence, and inverse existence. If any set satisfying all these three with respect to the operation star, then that will become a group, right? So set of integer with respect to the operation addition is a group. Set of real numbers, that is the group with respect to the operation addition as well as multiplication, right? So these are the group. But set of natural numbers, set of integers with respect to multiplication, they are not group.